right, here we are. The start of week 2. Don't forget to sign in and put your homework around that table right there. Start of week 2. I want to point out, right here is week 2's module that's posted. All right? And then you go to assignments. The same place you find the assignments is also where the answers are posted. So you go back originally where you got the assignments, and so tonight you'll see the answers for homework 1 posted right where homework is. Right underneath these 3 will be 3 answers right below there. So that's where you find the answers. Why would you check the answers? Oh, if you were absent today, you'd want to know if you had a missing item, that's for sure, because you'd want to get the missing item in as soon as you can. But since it's already past 11 o'clock, your best bet would be to wait till tomorrow to hand in the missing item, because you can look at the answer, which will guarantee you the maximum amount of points then, right? All right, just make sure everybody gets how this works. All right, is this where the video starts now? Is this where we start? Okay, we'll start the video now. Anyway, has anybody watched the video and can tell me, can you hear it?
Yeah.
Can you see it?
I couldn't see the board.
You can see that?
I can't.
You can't see that?
There's a glare, like there's that light.
That's
right
what I
there.
was afraid of.
Yeah.
Okay, so what I did on this one, and we'll see how it turns out, is I made it a little wider, like, I don't know, less than 100%, and all of a sudden it went a little darker, and I thought, oh, that's gonna maybe take care of the glare, because I wondered if there was a glare on that. Okay, so hopefully I'll get that fixed. Let me know if anybody gets a chance to watch today's video sometime before Thursday, if I got rid of the glare or not. All right, new material. What are we gonna talk about? I wanna refresh this, because I thought this was, I wanna make sure you got this percentile thing. That little rule, do you remember that little rule? And here it is kind of in words. You're going to, if you end up calculating, when you're trying to find a percentile, and it's telling you what position, and you calculate a position, which is I in this case, and it's an integer, and it is an integer, not, it is an integer, like 26, 52. That's when you go not only to that position, but the next position also. Whatever numbers are in those 2 positions, you add them together and divide by 2. But if this calculation ends up being a non-integer, something like 26.1, 52.7, has a digit after the decimal, then you know you must round up. That's the weird part. No rounding down. Even at 52.1, you're rounding to the 53rd position. That's the part a lot of people forget. So I'll make sure you got that. Here's the perfect example, the 80th percentile. So we took 80 divided by 100, which is just 0.8, times however many pieces of data, which was 70, and it came out to 56 on the nose. That's an integer. That's why we had to go to the 56th position and the 57th position and find those 2 numbers in those 2 positions, and then add them together and divide by 2. We only do that if that calculation is giving us a position that's an integer. So give me another percentile you'd like to calculate. Make one up, anything other than 80. 75 percentile. So we would take 0.75 times the number of pieces of data we have, which are 70. I don't know my calculator, but hang on. You guys are supposed to be the calculator. 0.75 times 70 equals 52.5. Okay, I'm going to stare at this now. Let me get the calculator out of the way. Hang on. I'm going to stare at this. Okay, I got an answer. What is the answer? What is the answer to this? What should be right here? What is this equal?
53.
I'm up 553? No. 5 what? I heard it over here. 525. 525. Now why is it equal 525? Because what he did is he said, if this calculates to a non-integer, 52.5, we must round up, so we're going to the 53rd position. So we go 10, 20, 30, 40, 50, 1, 2, 3, there it is, 525. In this row, the 3rd one over, 53rd position. Okay, give me another percentage, an odd one, not so common, like 70.75, something odd, a weird percentage.
12.
12? I heard 12%. Here we go. 0.12 times 70 pieces of data equals, hang on, 70 times 0.12 is 8.4, so this equals 8.4. Again, let me get this out of the way. I've got an answer. What's the answer? 440. What she did, she said, this came out to 8.4. It's a non-integer. We must round up to the next position, which is the 9th position. When it crossed the top row to the 9th one over, 440 it is. Okay, we got it. I think we got it. Now, quartiles. I want to refresh your memory on quartiles. We happen to have done the 3rd quartile right here, just by coincidence, right now. So there's the 3rd quartile, 525, which was position 52.5. The 1st quartile is the 25th percentile, so we got to do 0.25 times 70. Somebody get ready with that. And then the 2nd quartile is the median, which is also the 50th percentile. So let's just do it as a percentile, 0.50 times 70, which we know is going to equal 35 on this one. 0.25 times 70? 17.5. 17.5, thank you. And we already did this one. We know this is 525. Let's start with the 1st quartile, position 17.5. Whoop, let's get them back the rents up here. Position 17.5, 10, 11, 12, 13, 14, 15, 16, 17.5. I got it. What's the answer? Someone tell me what is this one? Come on, not all at once. You guys said all at once. I couldn't understand you. What? 445. 445. Because she rounded up to the 18th position. And if you go 10, 11, 12, well, 20 is 450, 19 450, 18 is 445. Right there. Okay, the median, or the 50th percentile. Now look at what happened. We got to do something here. What do we have to do? Because it came out to the 35th position. I heard it. Say it. That's right. She's saying go to the next one, add the 2 together that are in the 35th and the 36th, divide by 2. If I recall, they're the same number. This is going to be easy, isn't it? 35. So 10, 20, 30. 1, 2, 3, 4, 5. Is this 1, 2, 3, 4, 5? Is that that? Huh? 10, 20, 30. 1, 2, 3, 4, 5. And 36. 35, 36. Right here, these two. Right? Yeah? Come on. Yeah? Okay, we're together? Look at, they're the same number.
Why do you go to the next row? I thought,
Because that's technically 40.
Oh, that'd be 40 right here. That'd be 40 something here and 20 something there. So right there, 475 plus 475 divided by 2 equals 475. Are you ready? When you get the 3rd quartile and you have the 1st quartile, you subtract the results. So tell me, what's the 3rd quartile? I lost it. Is this it? 525. That's the bigger one, minus the 1st quartile, which is what?
445.
445, very good. And that equals what? 60, 70, what is that? 80? I don't have it written down. What does it equal?
80.
80? You just found the interquartile range. So let's review that. If you're asked to calculate the interquartile range, you first got to find the 3rd quartile. You then got to find the 1st quartile. Once you found that 25th percentile and 75th percentile, you then take those results, not just the positions, the results off the data, and you subtract them. That's called the interquartile range. The interquartile range is an important range compared to the normal range. Let me tell you what the normal range is so I can tell you the difference between the two. The normal range of data is you got to find the largest piece of data and subtract the smallest piece of data. That's the normal range. So in this case, help me out. This is now range we're doing. The range, what's the largest piece of the data?
615.
I heard you, 615. Minus, what's the smallest piece of data? 425, there we go. Tell me what we got, just under 100, looks like 90, is that right? Where's my calculator? 615 minus 425, 190?
Yeah.
190? Okay, 190 is the full range of this data, but the interquartile range, which will always be a smaller range. The interquartile range is always smaller because what it does is it gives you the range of the numbers that are in the middle. And it eliminates what are called outliers. Let me give you an example of an outlier. If, hey, who's in charge of that? If this were 715, or let's say 815, that last number is 815, it's so much larger than the one before it, it's so much larger than the rest of the data, it's so out of place, if this were 815, that it would be called an outlier. It's like a piece of data that's either way larger or way smaller than the rest of the data that doesn't make sense. And usually there's a reason behind it. If this is 815, maybe it's we're trying to call only efficiency or one-bedroom apartments or something, and somehow there was a miscommunication, and this piece of data that, let's say it said 815, was really from a two-bedroom apartment because of a miscommunication or something. That can happen. So that's called an outlier. Or if we had one at the other end that was only, let's say, 212, rent for $212 a month, that would be an outlier, so far below any of the rest of the rents, it's way off the chart. And so interquartile range eliminates outliers. It gives you the range of the center 50% of the data, from the third quartile to the first quartile. Can you calculate the interquartile range if you're given a set of data? The key is, you gotta remember to put the data in order from smallest to largest. Notice, every time we went here on percentiles to find it, we had the data in order from smallest to largest. Because what a lot of people forget is you're calculating the position, not the answer. I can't tell you how many people are gonna give me the answer here of 17.5 and 35, or they might round up. They'll round that up to 53 and that will be the answer. Forgetting that that means 53rd position, that you gotta go back and look at the data and find that number, 525. It's a very common mistake on either the first quiz or exam or wherever this question is gonna be, because it's coming. All right, so how do we feel? We got this already? How are we doing on time? We're ahead of time. Let's look at something. We're ahead of time. Let's look at something in case you're bored. Hang on. Hang on. All right, look at, come on. Hey, do you see everybody getting out of, anyway. I think that would have been fun to be trapped in the desert. Is that just me? Except for the restroom thing. That would have been bad. Anybody know what I'm talking about? Yeah. Yeah. Thousands of people got stuck there because of the pouring rain and everything. Does anybody not know what I'm talking about?
What are you talking about?
This festival out in Nevada that in the desert, they got pouring rain and thousands of people got stuck out there. They had to cancel the whole thing because nobody could get in and out because of all the mud. And they were stuck there for how many days until, I think late yesterday, they finally had to start leaving. They just stopped everybody from going because it would have caused so much mud that it would have been awful. So they had to wait for it to dry, which didn't take long once the rain stopped. Here we go. I wanted to look at, first of all, look at what's happening today. People today were losing money. Oh, no, that's cold. Sorry, my bad. Hang on. Look at the market. Why are we looking at this market? Why are we looking at this market? Why, S&P, what does that mean? We're down a 0.13%. We're just down a teeny bit, like nothing. But why look at this? Why would you ever be interested in wanting to see something like this? Because if you finish, and I hope all of you will, you'll have a degree, which means you're about to make more money you ever made in your whole life. Which means your employer is going to say, hey, welcome to the team. Can you go to human resources and let them know how you want your retirement distributed? And you're going to have 15 mutual funds in front of you, and you got about maybe 10, 20 minutes to decide how much of each time you get a paycheck, you get a certain amount of money put into a retirement program. And you have to decide right then how that money's distributed into, okay, I want to go with an income fund, I want to go with a money market fund, I want to go with a bond fund. You don't know any of that. Maybe some of you do. But most of you have never had to experience that before. You've never had a job where they're paying you a retirement as part of your career. Once you start having money in the market, you start to go, wow, how do I make this into more money? And that's when you start looking at things like this. And you start realizing, how does the market work? Because, gee, my employer is putting a bunch of my money in there, and their money in, they're matching it. Many employers will say, look, if you're willing to put in 5% of your paycheck into every time you get paid, 5% into retirement, they'll match it. And you will double your money the moment that you get paid on payday. That money that went into retirement, because they matched it for you. Now your person sitting next to you said, no, I can't afford to do the retirement. I need that money. I got 3 kids and my mother-in-law living with me or something like that. I don't know. Right? So they can't afford it. What they're missing out on is all that free money because they didn't do the retirement. All that matching. You're getting the matching and they're not. That's a lot of money over a few years. And that's when you become interested in the market, because you start realizing, wow, look how many thousands of dollars do I have in the market now. I better start looking at what it's doing. Why did I select these mutual funds when I got hired at this job?
How if they lose that money?
And well, yeah, they could be losing. Absolutely, if it's in the market, you can lose it. Right now, today, people are losing on average about 1.16% of what's invested. But here's what I really want to talk about real quick. Crude oil, 86.98. Does anybody remember what it was Thursday? When we did this, where is it? Right there. 82.81. What is it today? 86.98. What does that mean a couple days from now? Huh?
Gonna drop.
No, not the oil. What does that mean for you? What does that mean for you personally? Did anybody drive here?
Yeah. Gas is gonna go up.
Gas is gonna go up. There's a direct correlation from that crude oil price that we're looking at right there. Whatever direction that goes in determines the direction you are gonna pay, we all are gonna pay at the pump
Shit, I'll switch it.
when we go to eat gas. So, just so you know, just plan ahead, because in about 2 days, that usually is about a 2-day lag. When it goes up, it happens real fast at the pumps, it seems like, but when it goes down, it seems like it takes time for the price to go back down. I don't know why they do it that way, but, you know. How do these gas stations all know to have the exact same price?
Call each other. All the time.
Yeah, I don't think so. Nobody calls their competitors, but, all right. That was a break in the action, let's keep going. We did quartiles, we did percentiles, Excel workshop, Thursday, right after this class at 12:30 in this building, 153, which is like that first hall way down there. You guys are gonna go over Excel formulas, pivot tables, frequencies. It's all the basics of Excel. If anybody feels they want a refresher, it's only an hour long. All the other statistics students from the other sections are being asked to come do it if they want to. So, and all the other majors are being asked, not just business majors. But so it's open to all majors. If you want a refresher, I'll remind you on Thursday's lecture that it's happening right after class at 12:30 to 1:30 if you want us to take an hour out and do that. So there's that. Next, practice problems. Hang on. Where am I? Right here. Let me zoom this in. All throughout the book are practice problems, and what's nice about these practice problems is the answers are in the back for the even, I think it is. I don't know if it's every even, but most even. So we just did homework with mean, medium, and mode, and I noticed on page 91, look at problems, it looks like problems 1, 2, 3, and 4. All are asking for the mean, median, mode manually calculated from these numbers. And so 2 and 4 probably has the answers in the back to confirm you're doing it right. So as this class goes on, every time there's a homework assignment, there are some matching problems in the book, because when we first started using this book, I assigned the problems out of the book, but I knew all the answers were out there after the first semester you use a new book. So then I created new problems, but I designed them just like the book. So if you're looking to practice problems, just go to the book, to the section that we covered, and you'll find problems just like the homework, because I designed the homework like these problems, and the answers are in the back. So there's that. Practice problems, Excel workshop. We're going fast. Okay, let's get into the good stuff. Here we go. This is the heart of today's lecture. The heart and soul. You ready? By the way, if you want to talk about range again, there it is, 190. Oh, hang on. What did you tell me? There it is on slide 25, the full range. The largest number is 615, 425, just like we had right here. 190. The interquartile range was up here also. No, it's right here. There it is. The third quartile, which is the 75th percentile, 525. The first quartile, 425. The range is 80 for the interquartile range. Slide 27. I notice a lot of people use these slides for the multiple choice questions on the quizzes in the exam. And then usually the answers for the homework are kind of a good guide for the problems on the exam, or on the quiz and exam. So now, here's the empirical rule. Here's what it is. I need for you to figure out how to connect this empirical rule to what you're gonna see for the first time, at least in this class. Whoop, where is it? The Z chart. Now, let's go back to this empirical rule. This empirical rule says that underneath the bell curve, once you know the mean, that's supposed to be mean. Okay, once you know the mean and the standard deviation, you can find 3 numbers above and 3 standard deviations below the mean. And in a normal distribution, in a sampling of data, whatever it may be, let me give you an example. I like to use ball bearings a lot as an example. Let's say you're an inspector for quality control and you are assigned to go to the supplier of ball bearings. And you go there and your job is, there's 10,000 ball bearings they just made and they're ready to ship. They can't ship till you approve the shipment, but you have to make sure the quality's good. You know that what's acceptable is, I'm making this up, a 4 millimeter diameter ball bearing with a standard deviation maybe of 0.5 millimeters, something like that. Whatever it may be, whatever I'm trying to describe, let's just use this. 98 plus 10, plus 10, plus 10. Same thing with those little ball bearings. It'd be 4, 4.5, 5, 5.5, something like that. Even something smaller than that. In real life, by the way, how this is done, I've seen this done, is you would open up your laptop, you take the USB thing that measures the circumference of the ball bearing. You're randomly grabbing ball bearings and putting them in there. It circulates it, you take it, you put it aside, do the next one, next one. This machine that you're putting those ball bearings in is exactly taking a sample of what the circumference or the diameter or whatever it's measuring of each ball bearing. What we're gonna find from that sample, let's say you're only pulling out 30 of them. And you're taking that 30, put it aside, and you're gonna do another 30 now. And you may do this 4 times. And if all of these ball bearings fit within the certain amount of standard deviations, if it fits within, you're now approving that order to be shipped, which means now the company is gonna pay for it because they feel good about the quality. This is how everything changed in the auto industry many years ago, before you were born, is this quality control technique. Not just quality control in the manufacturing process, quality control through the suppliers that are providing parts to the manufacturer. They're manufacturing, this whole plant over here is doing brake pads and only brake pads. And they're making sure, they have their own quality people making sure those brake pads are exactly to spec. And then the company that's gonna take those brake pads, General Motors or Ford, they're making sure, they're sending someone over to make sure that quality is to spec before they allow that order to be shipped to them. And they're gonna pay for it. Now here's the deal, the supplier said, once you get denied an order, so the quality control person comes over and says, I can't sign off on this order, there's too many ones that are not fitting within the certain amount of standard deviations that we agreed to, you have 10,000 there that have to either be figured out which ones are good and which ones are bad, or completely redo all 10,000. The amount of money it takes for a supplier to do that is unbelievable. They've lost any form of profit on that order because it didn't meet quality control. That's when suppliers realize we need our own quality control. We never ever want to have that happen again, to have an order denied after we made 10,000 of these. So they have, now all these suppliers have their in-house quality control people. So if you ever say, God, this class wasn't bad. By the way, we finished this semester doing quality control, and you start the other class in quality control, and you're also gonna get quality control in operations management, which is another required class, I think, for you guys. Is that right? Operations? And you're gonna get into quality control there. And if you find that interesting at all, it's a great entry-level job to get your foot in the door of a company. First of all, most employees are impressed with quality control because you're working with math, and most people hate math. So that's the first thing. And you have a lot of opportunity because you're in there as quality control. It kind of means you have a specialization or that you know numbers, which means you're going to have job opportunities within that company because you got your foot in the door through quality control. Inventory management is another great position to get your foot in the door at a company, you know, at an entry-level position. So, what the deal is when you're taking that sample of 30, the empirical rule says 68.26% of all of those ball bearings are going to be between one standard deviation above and below the mean. And that's almost always true, right around there. And 95.44% of those ball bearings are going to be between 2 standard deviations above and below the mean. And 99.72, if they're made correctly within the standards that we talked about, 99.72%, almost all of them, are within 3 standard deviations above and below the mean. All right, so now you have enough information to determine the percent of that bell curve. Now, I want to remind you something. This whole area, if I could shade all of this area in underneath this bell curve, all the way out here, all the way out here, that equals 100%. So, this is the exact middle, and I think I said last week, there's a certain percent to the left and a certain percent to the right underneath that bell curve. If you had a dotted line, if it was straight, right down the middle, what percent to the left? What percent out of 100 is to the left of that line? 50. What's the percent to the right? 50. Very good. Now look, let's pretend I made another little line right here. This probably isn't accurate, but let's say I made another one right there. And I said to you, hey, from that line over, it's 40% of the bell curve. Then I said to you, what is it from that line to the right then?
660.
There you go. Everybody hear that? Whatever the percent is from a certain point on this line to the left, the exact opposite would be to the right. So if you can find, if I said, hey, what's the probability from -2 standard deviations to the left? Then you found that probability. But the question then, the next question says, what's the probability from -2 standard deviations to the right? You just got to say 100% minus what I just calculated to the left. It's the opposite. 100% minus whatever we just found to the left. This Z chart you're about to learn always gives you the probability to the left from any point on that number line. From all these different points on the number line, 2 digits to the right. So let me give an example. Ready? We're going to learn how to do this calculation to find what's called Z. But all Z is telling you the number between negative and positive 3 on this number line, that whatever number we're asking about falls on the number line, wherever it falls. This will make sense as I get to, I'm going to go full circle. This will start making sense in a minute. But hang in there with me. And hang on, I forgot what I was going to do. Oh yeah, from the left. And we do this calculation, and we end up getting a Z of -2.85. And I said, what's the probability, where is -2.85? Let's say it's about right here. And I said, what's the probability from that number, whatever number's there on the number line, that ends up calculating out to be -2.85 or less, to the left, or less would be the word, or less. So you would look up, you just calculate -2.85. And now you're going to look up -2.85 on the Z chart. Here's how you do it. That first column is the first digit to the left of the decimal and the first digit to the right of the decimal. That's all you're looking for in that first column. All the other columns are whatever the second digit to the right of the decimal is. So ours is -2.85, so start by looking for -2.8. Does everybody see it up there? And I'm going to put my pointer right by it. There's -2.8 right there. But now, the number we want is based on the second digit to the right, which happens to be a 5, so we got to go to the column. If you add if you take -2.8, the second digit will be along the top. So we got to go to the 5. So I'm going all the way over, -2.8, staying in the row, 5. There it is. The probability of the number, whatever it is we're doing here, being right there, whatever that number is, and it calculates out to be Z of -2.85, that or less is, look how small that is, 0.0022. 0.0022. I'm gonna change it to a percentage. You can leave it in decimal. That would be your answer right there. But if you want to turn it to a percentage, just move the decimal 2 places, 0.22%. I'll accept either answer, 0.22% or 0.0022. Okay, now here's the tough one. The calculation, or the question says, what's the probability of you calculating a negative 2.85 or more? Not or less, or more. What do we do? Find the opposite. Find the opposite. Ready? I'm gonna change it to a percentage. 100% minus, what is that? 0.22% equals the percent to the right. That's gonna be a big percentage. 90 something percent, right? 99 point something? What is that?
99.78.
Minus 0.22 is 99.78%. 99.78%. From that point, right there on the number line, really close to that -3, the amount of area underneath that bell curve to the right is 99.78%. The opposite of what this chart tells us. The Z chart is always giving us something to the left. Let's do another one. I'm gonna make sure you get this. Now back, I'm gonna take it a step farther. You ready? I'm gonna use these numbers. So now we can put it all together of how to use this, using these numbers. The mean of your data is 98, and your standard deviation is 10. We got a big barrel of things here that have a mean of 98 and a standard deviation of 10, whatever's in this barrel. It's a whole sample of this junk, whatever this is. I'm about to pull one out. What's the probability the one I pulled out is 88 or less? That it's a number 88 or less, or it weighs 88 or less, or whatever these numbers represent. 98 is the mean, 10 is the standard deviation. I just pulled one out, and I said, what number did I say, 88? Yeah. 88 or less. Ready? It's whatever you're being asked about, 88 or less, minus the mean, 98, divided by the standard deviation, which is 10. Whatever you're being asked about, is right there. The mean, use parentheses because you've got to subtract first before you divide, and then divide by the standard deviation. We're heading to where you're going to be dividing by what's called the standard error, but right now we're just using the standard deviation. All of these questions, the sample size is just 1, so that's why we're using the standard deviation. This will make sense as the class goes on. So, what does this equal? Tell me what this equals. What's 88 minus 98? Negative what?
10.
Negative 10 divided by 10 equals what? Negative 1. Now look at the number line. Where did 90 or 88 fall on the number line? At the negative 1. What I just showed you is how you're taking whatever data you have and turning it into a number on the number line between -3 and +3. I mean, sometimes you can go above there, but most of the time, every one of our calculations are going to be between -3 and +3. And then you just look it up and answer the question. You ready? Here's the question now. I'm going to turn it into we're already in week 3. Here's the question. Hey, the mean of this stuff, whatever this is 98, and the standard deviation is 10. We're going to pick one out of this barrel. What's the probability this one we just picked out is 88 or less? 88 or less. We've got to turn our question into one of these numbers on the number line. How many standard deviations away is that number from the mean? We get a -1. We go here, we're looking for, by the way, this isn't just -1, it's -1.00. So we're gonna have to use this first column because the second digit is a 0. But we gotta find 1.0, -1.0, and then we use the first column because the second digit is also an 0. So I'm scrolling down to find -1.0. Before I go down there, look at what we can do. We can use the empirical rule to figure that out. You have enough information to tell me what's between every one of these numbers. From that number to the left, from that number to the left, from that number to the right, from that number to the right. You have enough information there to tell me everything. For example, I want to know the probability right there, right here. how much of the bell curve did I just shade in if this bell curve's 100% and I'm at -1 to the mean? And by the way, between -1 and +1 is 68.26%. So what percent of the bell curve is from -1 to the mean? How would you calculate that, algebra experienced people you are? Go ahead.
Wouldn't you do 68.26 divided by 2?
That's it. If this whole thing is 68.26 and these are exactly the same size, because this is a symmetrical bell curve, even though it's not, because my drawing's awful, but in the real world it would be symmetrical, then you just take that 68.26 divided by 2. So 68.26 divided by 2 equals, this would be, what is that, 34.13? 34.13, let me turn it into a decimal, 0.3413. That would be that little area. Now, what is the amount of bell curve from that center line all the way to the left edge, all the way as far as you go, from the center to the left? What percent? 50. Very good. Don't forget, half of that bell curve is 50 to the left, half of that bell curve is 50 to the right. If half of that bell curve is 50 to the left, hang on, 50, and I want to know what the percent of the bell curve is from that -1 over, I can use that piece of information I just calculated, that spot right there, and if I subtract that little spot right there from 50%, I have found the percentage from -1 to the left. So what was that one? That was 3413, so 50 minus 3413 equals, that would be 15, that's 15.77? 15.77?
87.
87?
Yeah.
She's the only one hitting the calculator. Anyone else?
87.
Is it 15.87?
Yeah.
15.87%, or I'm turning it 0.1587 from -1 to the left. Let's check and see if we're right. Now we just used algebra and the empirical rule to figure it out, but now let's use the z-chart to see if we're right. From -1 to the left, did we get 0.1587? So we're going to use the first column, and we got to go down to -1.0. There it is. And the first column, right there, right above my cursor there, 0.1587. All this z-chart is doing is figuring out from any point on the number line to the left. You can use logic to figure out any point on the number line to the right once you know the z-chart. And all your calculations that you're going to be doing this semester, a lot of them are just like this. And all really what you're doing is just finding that spot between -3 and +3, so you can find the percentage of that bell curve that's underneath there. Does everybody see how easy this is? I just want to make sure. Go ahead.
Why did you divide the mean by 2?
Well, I didn't divide the mean by 2. I divided, it's the empirical rule. Matter of fact, let me put it up on here so you can see it better, because you can't see it up here. There. See how it says 68.26%? And see how the dotted lines go to 1 standard deviation below and 1 standard deviation above? It's saying that that area between here and here is 68.26%. So if I want to find that area on just half of this, or that side or that side, underneath that bell curve, I can just take the 68.26 divided half. Now I know the area right there. Now I also know that's 50%, so if I take 50% minus that area I just found, I can find that area. So without even a z-table, where the z-table comes in handy, that you can't use algebra to calculate, is when we start getting calculations of numbers between the numbers. -1.55, -2.87, +1.36. Those numbers between the numbers is then when we go to that z-chart to find the answer, because you just can't use algebra then to find the answer by the empirical rule. I want you to be prepared for your homework though, because I believe you have 2 questions where you have to use the empirical rule, these numbers right there, to show me the math, and there's like 6 different ways to calculate these. So everyone, you could go a hold of a classmate and say, how did you calculate this? And it could be a completely different way for you to calculate it, completely different, but you're both going to get the same answer. There's just so many different ways to do it, because there's so many different approaches you can take. But you have 2 questions coming up due a week from today, where you have to use the empirical rule numbers to show the algebra how you came up with whatever it's asking for. It might be asking for, what's the probability between these two, or between here, or from here over or from here over. Whatever it's asking, you gotta use the empirical rule and algebra to show me how you logically got the answer. This is all about you using analytical thinking with the information you have. You have 100%, you know the 50%, and then you know these three numbers. Those 5 numbers will lead you to answer any question about any one of those spaces. I'm gonna show you on Thursday the homework assignment itself and go into more detail as to how to do it. So I don't want you to think, hey, I don't quite understand this. Don't worry about it, because it's gonna clear up on Thursday. I'm going over all the homework assignment on Thursday, by the way, so that you're prepared to do it on Tuesday. Now, here's what I hear every semester, and I just want to pass it on to you guys, is, boy, when I attack that homework right after your lecture while it's fresh in my mind, it seems so easy. But if I wait 3 days and forget the lecture, it does not seem so easy. So I just want to tell you that after Thursday's lecture, if you kind of set aside some time to attack that homework, you'll probably find it very easy compared to waiting a few days. Because everything's so fresh in your mind, because I'm going to go over exactly what needs to be done on the homework on Thursday's lecture. All right, how we doing? How we doing in time? Let's do another. I want to make sure you get this. Are you ready? I want you to try it and tell me what Z you get. What's your Z you get? You don't have the Z chart, even though it's posted on there. I'm sure a lot of you don't have the Z chart open. But calculate the Z. If I said to you, well, here it is, the mean is 98. Do I answer the question before I go into this one? Go ahead.
What was your first question? What was your first step after you found negative 1.00?
What was my first step after I found what?
Negative 1.00.
Oh, after that, then I looked it up on the Z chart. Hang on, let me bring it up again. And I looked it up right here. See how I got negative 1.0, and then the next digit is another 0, so I had to use the first column, and there it is, 0.1587. See it? So after I did this, I then went to the Z chart and looked it up, which is what we're going to do again right now. You calculate what you would look up on the Z chart. If I ask the question, now I'm going to get this, is going to be an odd one. If I ask the question, what's the probability we pick one out of that barrel and it's 79 or less? We picked one out of the barrel and 79 or less. What's your Z? You got your Z? What's your Z?
I'm asking
What's this? Actually, go ahead. Say it.
standard deviation.
What is the standard deviation? The mean is 98 and the standard deviation is 10. Still 10. The mean is 98, standard deviation is still 10. What's the probability? You pick one out of the barrel and it's 79 or less. What's your Z? Nobody.
Negative 1.9.
Whoa, I hear negative 1.9. Anyone else get confirm that or a different one? Yeah, what? Negative 1.9, negative 1.9. Let's talk about how they got it. They said, formula says, whatever you're being asked about, minus the mean in parentheses, divided by the standard deviation. So we're being asked about 79 minus the mean, 98, divided by 10, parentheses around that subtraction, because that has to be done first, equals negative 1.9. Now, if this were a quiz question, it would say, now, what's the probability of getting 79 or less? Remember I said or less. Now we're looking it up, because this Z chart always tells you or less. By the way, what's the next digit after this 1.9? What's this next digit?
0.
0. So we go to the 1.9. I'm going to scroll up a little so you can see the top numbers. This is negative 1.9. There's negative 1.9. The next digit is 0. The probability, I've got my pointer right next to it, equals 0.0287. Is that what it says? 287. There's our answer. You can leave it just like that. If you're a numbered person and you want to turn it into a percentage, move the decimal 2 places, it would be 2.87%. I'll take either answer. Don't turn it into a decimal or into a percentage. Leave it as a decimal if you're not comfortable with moving that decimal over 2 places. Leave it as a decimal.
And then you subtract that from 100 to get the...
He's going to my next question. My next question is, what if I said, what's the probability we drew one out of the barrel and it's 79 or more? 79 or more, so what? 79 or more. And he's saying, would we have to recalculate this? No, we already know it's
Minus.
yeah, everything, the calculation is the exact same thing. The only step we gotta add is take our result and subtract it from 100%.
Isn't it like
So I'm doing it in the decimal this time. 1.00 minus 0.0287. Yeah, that's some zeros there. equals,
97.13.
say it again.
Is it 97.13?
0.97, he's saying 0.9713. Someone confirm that?
Yeah.
There we go.
100 minus 2.87.
So that would be for 79 and above. So from here's 78, 79 is right there. From right there underneath the bell curve to the right is 97% of the area under the bell curve. From right there to the left is only a little less than 3% of the bell curve is to the left. So you can see how little portion of the bell curve is over here in the tails compared to this big part in the middle. I mean, just one number over, you're adding a big percent from the mean. How do we feel? Did everybody feel comfortable that they could get that z of negative 1.90? That was the whole point of that exercise. I want to do one more. I need you to feel comfortable. You can calculate the z that I'm asking for to look it up. The mean is 98, standard deviation is 10. We're drawing one out of the barrel. What's the probability it's 115 or less? 115 or less. What's the probability it's 115 or less? What's the z?
1.7.
Oh, look at you guys. 2. So they said, being asked about 115 minus the mean of 98 divided by the standard deviation of 10 equals, was it 1.7? 1.7, what's the next digit? 0.
I got it. 0.955.
He's looking it up on the z chart already. We're gonna go to the positive though. Hang on now, this was the negative z chart.
955.
Hang on. See, the negative z chart gives you all the numbers that are negative to the left of the 0, and then all the numbers to the right of the mean is down here. So we gotta go to 1.7, and then there's 1.7. The next digit is a 0. So there's our answer right there to the left of my cursor, right there. 0.9554. 0.9554. Is that what you got?
Yes.
Yes? Okay. Yes.
So if we get a question asking for whatever it is in less, for whatever it is in more.
Now would be the opposite of that.
No, I know, but do we always have to find the less first, or
Yeah.
is there a way to
Yeah.
find
This only gives you the less. You have to find there's no way of getting the more unless you do the less. You have to. There's just an extra step, subtracting that from 100%. That's the extra step for more. No. No.
When did you do it by 50? When you did 50? When you subtracted by 50, not 100?
I was using logic. I subtracted from 50% back here. Is that what you're talking about?
Yeah.
Because I knew that half of this is 50%, and I wanted to go from -1 over, and we had just calculated that space between there as half of that, so that's why I used 50. I could have used 100. No, see, I could have used 100 minus that and still got the same answer actually, but I still used 50 because I knew. I think I could have. Could I? I don't know. More, something like that. I don't know. Go ahead. Next question.
You want the more?
No, I don't want the more, but unless you're telling me it's 0.044466, 4.66?
4.46.
46, thank you. Percent for the more than. That would be for 115 or more. 115 landed where? About right there. There or more is a very small part, only like a little more than 4%, and from there to the left is 95.5%. A little more than 95.5. That's a lot for today. So that's why we'll finish on Thursday. Have a good 2 days. Oh.
So, you know?
When we gonna let the